the market needs of this technology. The agenda of the workshop is going to be as follows. We will have a set of presentation. The first one is an overview about the DeCAIR project with our director, Professor Ghaith Abanda. Then we're going to have 4 presentations about by our European academic partners to show their expertise in the area. Also, we're going to have another presentations that are going to be delivered by the speakers from the industry in Europe, Jordan and Lebanon. Before we start with the presentations, I just like to kindly bring your attention that you can send your comments and questions through the chat window, and we'll direct them to the speaker if time permits. Otherwise, they will be answered during the open discussion session. So our first presentation, it's an overview of the DeCAIR project with our coordinator, Professor Ghaith Abanda. Professor Ghaith, he's a professor in the computer engineering department at the University of Jordan. Professor Ghaith.
Okay, I'm going to share my screen now. I think you can see it. Good afternoon and welcome to DeCAIR Stakeholders Workshop. I'd like to welcome our stakeholders from the governmental and non-governmental organizations, the academia, and our current and previous students. I'd like also to thank all who have contributed to organizing this workshop, including our guest speakers, Erasmus Plus and its offices, our partners from Europe, Lebanon, and Jordan, and the wonderful DeCAIR team. This presentation is about giving an overview about DeCAIR project. It includes introduction about AI and robotics, the consortium of DeCAIR project, the project's objectives, grant, and planned work packages. As you know, AI is the new electricity. It has the potential to transform every industry and to create a huge economic value. AI now recognizes our voices and photos, recommends who to friend and what to watch and what to read, helps us in searching and retrieving information, translates natural languages, drives vehicles, secures our cities, systems, and detects violations, and provides cheaper solutions with acceptable qualities. Robots for decades have been providing efficient, fast, and reliable solutions for manufacturing many products. Trainable, autonomous, and agile robots are having increasing applications in our lives. With AI, robots can impact every aspect of our lives. AI and robotics technologies, we think that no country or business could afford being left behind in developing AI technologies and using them to provide better and more competitive products and services. Now, DeCAIR project, developing curricula for artificial intelligence and robotics, is a 3-year project started last month and funded by Erasmus Plus capacity building in the field of higher education program. The consortium of this project includes 10 organizations, 5 from partner countries and 5 from European program countries. 3 universities from Jordan, the University of Jordan, Jordan University of Science and Technology, and Tafila Technical University. 2 universities from Lebanon, the Lebanese University and Beirut Arab Universities. 2 universities from Italy, University of Pisa and University of Genoa. a university from Spain, the University of Granada, from Germany, University of Stuttgart, and from Greece, Creative Thinking Development. About the project objectives, we have seven main objectives, qualifying experts in the fields of artificial intelligence and robotics who can conduct research and solve problems by utilizing the technologies of AIR through the establishment of new master and bachelor programs, building and improving the teaching capacity in AIR at the Jordanian and Lebanese partner universities, improving the AIR capabilities of graduates from existing master and bachelor programs, establishing and developing modern AIR labs in the partner Jordanian and Lebanese universities to improve the practical skills of university graduates, building networks of highly qualified professionals in the areas of AIR among South Mediterranean and European countries, improving collaboration with the local, regional, and European industry and community for applying AIR technologies in solving industrial and community problems. And finally, disseminating and implementing modern teaching methods such as flipped learning and project-based learning. The Erasmus Plus grant is about 850,000 euros. 40% will be used to cover staff cost, 26% to cover travel and stay costs, and 30% will be used to buy new equipment, 4% for subcontracting costs. Now, for the planned work packages, we have 13 planned work packages. The first one in the preparation work package, where this workshop is part of this work package for surveys and needs identification. There are 8 development work packages for developing and implementing a new master's program in the University of Jordan and a new bachelor program in the Tafila Technical University. Also, there are work packages for improving current bachelor and master's programs in the Jordanian and Lebanese universities. Work package 7 is for building capacity in AIR in universities of partner countries. 8 is for establishing the labs, and 9 for implementing modern teaching methods. Of course, there are 2 work packages, one for quality assurance and one for management, and the dissemination include work package 11 and 12, which are collaboration with industry and community and results dissemination. This is an overview of this project. I have given an introduction about artificial intelligence and robotics. The consortium has 10 leading partners. The project objectives are 7. We have a generous grant from Erasmus Plus, and I hope that we will be able to carry out our planned work packages. Thank you.
Thank you, Professor Raith, for this presentation. I think now with Professor Lucia Ballatino. She's an associate professor at the Department of Information Engineering, University of Pisa. Professor Lucia.
Yes. Here. Can you hear me?
Yes, yes, Professor Lucia, we can hear you. I think you can share your screen.
Yeah, can you see them? Can you now see my slides?
No, not. Yes.
Okay.
Yes.
Okay, so good afternoon to everyone. I'm Professor Lucia Pallottino from the University of Pisa, and we are a member of the European project we are talking about, and we are mainly involved in robotics. So today I'm going to show you how is the master program in the University of Pisa organized, and which are the outcomes of our classes with respect to our students. So I will give you just an idea of what we are doing at the moment. So Pisa is in Italy. It's in the center of Italy. It's not far from Florence and close to Venice and Rome. And has a is famous for the Leaning Tower. I hope you have been here before. And has a very old university. It has been founded in 1343. And this is a university where we cover all the areas of the knowledge, from medicine to human science to engineering. So we have 20 different departments, many libraries and museums, and we have a high number of programs that will cover all the areas I've mentioned. But in particular, we work in the School of Engineering, where there are 3 departments, and we work in the Department of Information Engineering. And to enroll to any bachelor course of the School of Engineering, high school students, has to pass a test, where we test mainly mathematics. And if they pass the exam, they can enroll in any program of the school. And they can try the test more than once. So we have a kind of a filter at the entrance of the bachelor degree. We don't have any filter at the entrance of the master degree. Just to give you an idea on how we start working with our students. Our department is quite big. We have 95 professors and 50 postdoc students, and we handle programs for about 4,000 students and 100 PhD students. The bachelor's degree are on electronics, computer engineering, telecommunication, and biomedical engineering. So there are just 4 bachelor's programs, but we provide more than 4 master programs that are in electronics, computer engineering, telecommunication, and biomedical engineering as a continuation of the previous 4. But we do have also other 4 programs that are robotics and automation engineering, artificial intelligence and data engineering, bionics engineering, and cybersecurity. And those 4 additional master programs students can enroll in those programs coming from all the bachelors. Okay, so those are some pictures of the professors, the robotics professor of the course. So the master program we are working on and we are talking about today has the objectives to provide competencies to the students, such as how to identify and describe formally the models of the system they are working on. So it has a very theoretical approach. Then also, we want to give them the competencies on how to tackle complex problems in a multidisciplinary context, because systems in robotics cover from electronics to computer science to modeling, general modeling, mathematical modeling, and so on. So we need them to be able to tackle the problems with a multidisciplinary view. And then also to solve problems in a more effective way, both in terms of technical terms, so provide better platforms, so better technology, but also in terms, economic terms, so how to simplify the system so they can cost less. And then also, okay, other requirements. So we have, we do want them to have a very formal and very methodological expertise, but also to work with real systems. And that's the idea on, around which we developed the master program. So as I mentioned, this master program doesn't have a bachelor degree associated to that. So we allow students from several other bachelor programs to enroll in ours. And not only in our department, but also, for example, in the energy, in the management department, engineering management, the mechanical engineers and the energy engineers that are in other departments, they can enroll in our program, so as all the other bachelor students of our department. That's a very important thing that we think it's an important thing, because we attract students that have very different backgrounds, and we allow them to work together and to work on complex systems, so that they can help each other to learn the expertise that the others have. So we have mechanical engineering working directly with the software engineers, so that they can handle the problems together and they can learn from each other. And the outcomes of this program, and that's pretty obvious, is double-fold. So they can enroll in a PhD or apply in the industry, or have their own startup and go in the job world. So I just wanted to stress out the fact that our students, when they come, they have a very huge, they have huge differences in their background. So that's why when I will explain you the programs, we will provide them with basics of several topics. As professional collaboration and direct collaboration, and also more or less where our students will go working after our program, the area are the automotive sector, in general industry like manufacturing, the defense, the aerospace, the marine, and everything that is related to the control and automation technologies. And here I just plotted some of the companies that we work on with in several projects, and also where our students usually go. So the number of our students, just to give you your idea, when we designed and we thought about this program, we were thinking about having from 20 to 25 students per year in order to allow them to be in the labs. And this was in the early, it was around 2002, 2004. And then the program has and in the time, it was very attractive because robotics has been a keyword, very attractive keyword. So we ended up having like more than the triple of the students we were expecting. So now we are around, this year we are around 75, 80 students at the first year. So each year we have more students than we were expecting. So we do have to handle this with the labs. That is not easy to handle this amount of students in the lab. But that's just to give you an idea on how many students we have. And this is to give you an idea on what happens next. So after 2 weeks, they all work. They all have a job already. And the 2 weeks time is just because they want just 2 weeks to recover before they start working. Because when they discuss the final thesis, they already have a contract, signed contract. And so it's, I mean, more or less this is equal for all the degrees in the engineering departments. So it's not typical just for our master, but it's a very high number for everyone. And then we have also an average salary that is quite high, or now it's not easy to say if it's high or not, but for Italy, it's quite high. And then just to, as I mentioned before, mainly they go or in the industry or they do a PhD. We do have a lot of students that enroll in PhD studies, obviously in Pisa, but also in other countries. So they move and they go in other countries in the United States, but also in Europe to do the PhD. And if not, they usually go in the industry, in the ICT sector, and in electronics. Those are some percentages that are not very easy to explain, but just to give you an idea, because it's not easy to understand why electronics and ICT or industry are different. But this is not our data, it's a national database. So we don't really know how they decide what is ICT and what is electronics and why they're not together. So this is just to give you an idea on how our students are doing. And what I can say more than numbers is that in general, when we allow our students to work with the companies, they always are very, very happy, because mainly because these the figure that we are preparing for the job that is multidisciplinary. And why is that? Because those are the courses, just to give you an idea of the courses. They have some mandatory courses, like this one, the green ones, so they have to do them, all the green ones. And then they have to choose 12 ECTS among a set of courses, and then other 6 among another set of courses. And then they can choose freely, completely freely, 2 courses, of 6 ECTS each. And they can choose whatever they want, but they have to explain us why they choose those courses and why they are useful for their program. So as a mandatory courses, we have mechanics, robot mechanics. So it's very formal, very theoretical. Then we have a basic probability and stochastic process course. And then we have system theory and control theory course that is a 12 ECTS course, but it is divided into semesters. The first semester is system theory, the second semester is control theory, and that's the main course where they learn all the system theory that is fundamental for the whole program. And then they also have to do digital control. And then they have some non-mandatory, but they can choose among them, electronics, basically, and real-time systems. So this is mainly for students that do not come from an electronic bachelor. For example, this is one mainly for students that do not come from a computer science bachelor. And those are examples of courses that we provide to students because they come from different bachelor. So for example, a mechanical engineer that doesn't know a lot of electronics can take this class to have a knowledge on the topics, okay? Okay, in the second semester, we have process control, that is a 12 ECTS course divided in technological process control and sensors for robotics, and automation. And then they have control theory. So all these green are quite theoretical courses. Then we have control of energy systems, mechanics and mechatronics, lab, so this is a lab, and this is mainly for computer science students, and then I can choose one of the courses that I can choose during the program. While in so the first year is very fundamental, methodological, but in the second year, we provide them also some advanced courses closer to research. So they have another basic one is control identification of uncertain systems, that is divided in 2 parts. Then we have robotics, that is a nonlinear control, mainly control for robots. Then I can choose between vehicle dynamics and aerospace robotics, so they're very close to research, or underwater robotics in the second semester, cybernetics and physiological systems, modeling and simulation of discrete event systems, and then another course in robotics that is regards distributed robotic systems, so systems consisting in more than one robot, guide and navigation system, and the final thesis. So they work for more or less 4 to 6 months on a program and on a robot, on a real system. And so they can handle the electronic part, the firmware part, the mechanical design part, and they have a look of the whole system. They don't usually work alone on this, they work in a team, but they do both a theoretical part and a practical part. So that was just to give you an idea on what I was mentioning before, why we choose this kind of approach. And the laboratories are there. We have 3-4 laboratories. We have many different kind of robots and devices. I'm just showing some of them. So we have vehicles. We have an automated forklift, autonomous vehicle, and also very small vehicles for labs. Okay, and those are just 2 videos just to show you what we are doing with these vehicles at the moment and how they move around. So this lab is quite new, so we are just starting that. And we do have several manipulators that I'll show you. Here on the right, you can see the bimanual system with 2 KUKA manipulators. And then we have also a universal robots, and we have, this is a UR10, and we have 3 Franca Panda robots. And those are the main bigger robot. Then we have several drones and
So Lucia, you have just 1 minute, please.
Yes, I'm just finishing. And we have several devices like this one that is a hand, is a robotic hand that we provide, we designed, so we built. That is very nice because it's easy to use, and the student can do a lot of grasping also activities. And so we have also some devices like actuators or this end, or several wearable devices that we developed that are available to the students. So this is just some of the picture, those are the picture of some of the robots we have in the labs. So that's all. I hope this clarify what we are doing, and I'm here for questions if it's needed. If not, we will discuss this later together.
Thank you, Lucia.
You're welcome. Thank you.
Thank you,
I'll
Lucia.
stop sharing.
Yes,
Okay.
please. Okay, thank you, Professor Lucia. Now, with the developing conversational interfaces for the real world, with Mr. Nacho Montoya. He's a marketing director at Emergia. Emergia is an international company that offers a wide catalog of professional services, products, and solutions around artificial intelligence, digital strategies, and cloud technologies. Mr. Nacho.
Hello, can you hear me?
Yeah, we can.
Okay, hi. So let me try to share my screen.
Sure.
Yeah, yes.
Can you see it? Okay.
Yeah.
Hello. So thank you very much for having invited me to this forum. I'm going to make let's try to make a brief presentation of how we in our company are working with artificial intelligence in real world cases. Okay. So first of all, well, my name is Nacho Montoya. I'm currently the marketing director at Emergia. And Emergia is a company whose main headquarters are in Spain, in Seville specifically. And it starts with the dream of 5 telecommunications engineers 17 years ago. And today we are more than 600 people, and we have offices in different countries and cities, and as you can see. And we are currently focused on offering solutions around artificial intelligence and digital products, mixing both, based most of them in cloud technologies. Okay. So in our 17 years of life, we have had the opportunity to work with large companies and from different sectors, many of which continue to be our clients today. And we are specializing in offering vertical solutions, okay, by industry, and very focusing on solving specific use cases that in short time offer a high return to our clients. So our value proposition is based on 4 great pillars. And the important thing here is that all of them fit perfectly with the application of artificial intelligence technologies in the companies we work with. In fact, without these 4 pillars, it would probably be impossible to us to carry out many of the projects that started as simple proof of concepts. Because, well, now selling artificial intelligence sometimes is quite difficult and apply it in the real world with real budgets behind in the companies. So first of all, the most important thing is that we use agile methodologies, okay? So we start with minimum viable products, and this is not just a way of working, let's say, or doing projects. It's a way of interact with our clients and an internal culture. It's a way that also fits perfectly with artificial intelligence technologies that usually, as I say, start with proof of concept. And well, data is, of course, one of the most important parts of the equation. So if we focus on our client to have the data, the quality data that we need, and then we need to explode that data in any solution that we develop to make them to make informed decisions and to evolve from the data. And the cloud technologies as well, that is an accelerator, all right, for many reasons, including for the AI technologies. So this is our portfolio, basically, but we are going to focus on the artificial intelligence, all right, and specifically on the conversational assistant solutions. Among our partnerships, the most important related to artificial intelligence is the one that we have with Google Cloud. We believe that Google Cloud is really leading in offering artificial intelligence tools and solutions in the cloud. I will talk more about it later, but we are one of the few partners that Google Cloud has recognized as a specialist in machine learning, and it's really an accelerator, right? These are some examples of the artificial intelligence project that we have carried out. So we have the left some conversational assistants for big companies, but on the right we have different machine learning applications for forecasting, recommendation engines, location intelligence, for example, and all of them are, let's say, digital products, meaning that it's not just a project, or is not just R&D, but we create a specific value for the companies and for their customers. So let's talk about that conversational assistance, all right? So the thing is that the way in which business and consumers interact right now is constantly changing and evolving, and the coronavirus has further accelerated this change. And the consumers want the companies to be online, which means that they want to be available 24/7 and in any channel, etc. And in this context, depending on what they want to solve with the company, the reality is that more and more users prefer to interact with a well-functioning chatbot than with a human, for a matter of agility and speed. This is what it is called self-management models right now. So the users solve the problems or doubts by themselves. And another reality is that the companies are investing more and more in automating the user support. Sorry, maybe mainly to escalate the support centers, all right, in terms of number of channels, availability, and well, that would be very expensive without that automation. So assistants are in many cases becoming the first employee of the company, at least the first one that many clients meet or contact. So that's what they are becoming so important in the real world. And actually, the first chatbot was created in 1994, I think, something like that. So they were programmed based on conditional statements, if else, trees. And that means that if you did not exactly ask what the chatbot is expected to hear the way it was programmed, it will return a wrong answer. And that's exactly what makes a chatbot, let's say, annoying and unbelievable. And that's not the case anymore. Bots right now are becoming more and more usable and more capable. And they are built with AI, with artificial intelligence. It doesn't matter anymore if you spell your question wrong or if you say things in different ways. So the chatbot will understand what's being said and will detect the correct intention, right? So we are not talking anymore about chatbots. We are starting to talk about conversational experiences. So it's a chat interface that relies on natural language understanding for interacting with users. It's not based anymore on static and fixed scripts, let's say. So if we compare a conversation in terms of a human and in terms of a conversational assistant, there are clear parallels. First, you talk to it, and it takes your spoken voice and transcribes it to text. That's what we call speech-to-text machine learning model. And then it will understand, all right, the written text, and that's the natural language understanding, and it will match the intention. That is probably the most important thing. That is to find the correct answer, understand and classify what you need, and find the correct answer. And then it will read out the answer, synthesize it, but with WaveNet models, meaning that it sounds like a human voice, all right? So it's more a conversational experience than just to talk to a chatbot. And Google is really leading this when it comes down to machine learning, especially when we talk about speech and voice technology. So from researchers like DeepMind, TensorFlow Machine Learning Framework, and Google Assistant, speech APIs, and they also have a lot of data to build models on top of, including from Google Search, YouTube, and well, other nameless sources like Gmail, Hangouts, etc. All right. So Google has a series of technologies, APIs, tools, a lot of technologies focused on for data scientists. But at the top of them, it has created what they call building blocks, all right, which are products that are pre-trained machine learning models and with user interfaces that make it almost easy to use for non-technical people. That's really an accelerator to create a conversational experience. And the main one in the world of conversational assistant is Dialogflow. It is an interface that has integrated natural language processing that is pre-trained and allow us to program conversational flows in almost, let's say, a magical way, as some people say. So thanks to the combination with speech-to-text and text-to-speech, it allows us to go from voice to user intention and then to response in a much easier way than some years before, right? It doesn't mean that it is something simple. It is something that in the inside is quite complicated, has a lot of components, but the real good news is that we can make the things in a modular way. That means that we can really apply the agile models, and we can iterate, and we can evolve from a proof of concept to something more complex and more expensive. That's the way we can really go to the industry. You cannot go with something very expensive without a clear return of investment in a short period of time. So that's the first challenge that we need to solve. So what are the big challenges right now? If everything looks so easy, let's say, well, it is not. It is not so easy. So the thing is that in real conversation, what we are finding is that around the user is the real world, let's say. So the quality of the call is sometimes poor. There are background noises. There are several speakers interrupting each other at the same time. User don't always speak with the same accent, etc. So giving some examples, we had two conversational assistants. One we did for Melia Hotels, and another one for Mutua, that is one of the main insurance companies in Spain. So the Mutua assistant, M, is available on many more channels than the one in Melia. So it's available via web, mobile application. It's available via WhatsApp also. It's integrated with Salesforce. So it also has 1,000 times more users per month. And it supports many more concurrent interactions. and it also has more capabilities, let's say. The Melia assistant, on the other way, is only available by phone and for far fewer clients. But however, the reality is that the project of Melia was much difficult than the project with Mutuo. And this is due to the telephone and the voice factor, all right? So the reality was that the customers called from train stations, walking down the street, from a taxi, from, talking to other people, and that makes understanding and correctly identify the user intention many at times, sometimes almost impossible. So when you have text interactions with the user, is let's say very simple to make the system, but the voice right now is one of the main challenges for conversational interfaces in the real world, let's say. All right. And the other great challenge is not just a technical challenge, but it is at the end, is to provide the attendees with personality. So this implies that the conversational interface must have a specific tone, type of response. So it must use and don't use some words, specific words, and not others. Need to have their own style of speaking, and that is consistent. That must be consistent with the company. All right. So it's very important that if we want really to go from a chatbot to a conversational experience and to a virtual assistant, let's say, the personality is the key here. And this is something that needs to develop hand in hand with the technical people, because you need to count on the requirements that you have, and you need to count on what you can and you cannot do. Regarding, for example, with the voice, depending on the language that you use, you have available different voices. If it is a female voice, male voice, etc. All right. So we need to think that right now the expectation is really high with the conversational assistants. And in this context, the teams are increasingly multidisciplinary. We are putting people from humanities degrees to work together with data scientists, with computer technicians. So it is sometimes a challenge. It is something complicated to build that kind of teams. We are realizing that it is also a great opportunity. So what we are finding is that the energy and the value that are generated when we bring together people from so many different fields of knowledge and is incredible. It makes both the people in the teams and the entire company to evolve and to grow. And that's all from my side. I hope that I haven't run too much.
Thank you.
That's fine. Thank you, Professor Mr. Nacho, for this presentation.
Okay.
Now with Professor Francesco Massoli, talking about the European academic AIR experience, taking University of Genoa as an example. Professor Francesco, he's a professor in the Department of Computer Science, Bioengineering, Robotics, and System Engineering at University of Genoa. Professor Francesco.
Hello.
Hi.
Okay. Excuse me, it's nice. Okay. Good afternoon to all. I am Francesco Masulli from the University of Genova, that is a partner of this project, of the DeCAIR project. The University of Genova is one of the older universities in the world. We have 3,000 people as a staff and 40,000 students, and we organize in 23 departments. I am part of the Department of Computer Science, Engineering, Bioengineering, Robotics, and System Engineering DBRIS, that is the acronym. We are about 80 in researchers and professors. Okay, here there is the localization of Genova and some picture of the port, of the center, of the entrance of the main building of the university. And here there is our department and a teaching lab. Okay, we have a large environment of collaboration with the industries. Here I listed some on running collaborations with the direct contract and in collaboration in European and national projects. Okay, we have established many joint labs with companies from biomedical companies interested to use wearable sensors, to companies interested to augmented reality, cybersecurity, etc., and many others. The DBRIS hosts many spin-offs active on different areas of ICT. In the last 5 years, we were part of 150 industrial projects, 30. There is an echo. 35 international projects, 40 national projects, and we published a large quantity of papers, 1,500 in different conference and international journals. Concerning student training, we have many bachelor, master, and two now PhD programs. And the thesis or the final project of the courses of the programs are done in the research in the labs of research groups, in joint labs with companies, and through internship in companies. Almost our students get a job in few months after the degree, and they obtain jobs in regional, national, international companies, often working in R&D. Okay, the organization for the research, the organization of the DBRIS is informal. Research group are informal aggregation of researchers, but we can show here the main topics. In particular, concerning machine learning, pattern recognition, computer vision, computer graphics, DBRIS is in the top positions in the Microsoft academic search ranking. Okay, concerning artificial intelligence, there are about 15, but probably more faculties working on this field, together their research groups. In particular, my research group on computational intelligence is part of this aggregation of AI, and we have one of the spin-off called the research laboratories. Okay, the activities of people working in AI at DBRIS concern health, smart city, and industry. Okay, here there is an example of a very a running project concerning the use of cameras and microphones audio sensors in the positioned in the town in order to obtain information about security and traffic monitoring and prediction. The work is done in collaboration with the DBRIS with 2 companies. This is the sensor we already we have just projected, designed for audio sensoring in the town. Here there is another project concerning circular economy, and we are interested to find, to obtain precious materials like tantalum, antimony, but even gold, etc., from the West, electronic West. So in our aim is to select the homogeneous electronic components, like, for example, electrolytic capacitor, and go to this to obtaining the materials, the chemical materials from them with more quantitative result. So we use in this project with our students Jetson Nano from NVIDIA, that is aboard with GPU, and we organize this setup with the camera of the Jetson at the top and the electronic board to on this place. Okay. The results are interesting. I show here very preliminary results. The machine is able to distinguish iron from electrolytic capacitor, and the process is the one of the classical process of the machine learning. So we label some sample images, we train the deep neural networks, in this case YOLO, and then we perform object classification on the video streams. This technique is have other application like people detection, counting, and social distance measurement, and moreover we can use it for car traffic flow measurement and queue detection in medical images and so on. Okay, teaching at DBRIS, we have many programs at graduate, undergraduate levels, and PhD programs, one on computer science and another in bioengineering and robotics. At the level of a bachelor in computer science, we don't have any artificial intelligence robotics courses. The bachelor is in Italian, and we have 250 new enrolled students each year. Concerning the master in computer science, it is in English. We have about 50 new enrolled students each year. It is organized in 2 tracks, data science and engineering, including artificial intelligence, and software security engineering. So we have about 20 new enrolled students each year for the AI track only. Okay, this is a scheme of the organization of the course of the Master Science in Artificial Intelligence program. So we have the main courses are machine learning, digital signal and image processing, artificial machine learning, speech recognition, processing and recognition, computational vision, well-being technologies, natural language processing, multi-agent processing. This is the core of AI course in the curriculum. Then we have two relevant courses on data science. They are large-scale computing and data visualization. We don't have any robotics course in this program. There are other courses that, for example, additional useful knowledge. There are collection of seminars to be followed by the students. There is a course on topics on computer science that is used in order to fill some gaps of students that didn't follow the bachelor in computer science, but for example, in other kind of engineering or physics. Okay, we have a course on high performance computer and on security, data protection, and privacy. Okay, the teaching, each course including homeworks and a final project, or no course, no homeworks and only the final project only. We have two labs with many computers. They are called Software 1 and Software 2. And moreover, the homeworks, part of the projects and the final thesis of the student can be done in the research group labs where they can use advanced workstations and high performance computing facilities, and also NVIDIA, including sometime NVIDIA GPUs, but also edge AI on the edge systems like the Jetson Nano, and biosensor, wearable, and ambient sensors. So I think is all for my presentation. If there are questions, please let me know.
Thank you, Francesco.
Thank you, Professor Francesco. I think I have a problem with my screen. Okay. So now with Mr. Kevin McFall talking about bringing GPU accelerated computing and deep learning to the classroom.
Yeah.
Mr. Kevin, he's a master instructor at Deep Learning Institute, NVIDIA Corporation. He's delivering workshops, certifying DLI instructors, and generally supporting the DLI. Mr. McFall?
Yes, wonderful. Can you all see my screen and hear me okay?
Yep, sure.
Okay. Well, thank you, Francesco. You gave me a great introduction. You named NVIDIA products at least 3 times in your presentation. So thank you for the shout out there. Appreciate it. But you know, I've actually only recently joined NVIDIA. I've been here since November. And before that, my career has been in academia. I worked for 20 years as a professor. My last position was at Kennesaw State, and I was in a robotics and mechatronics engineering department. So I've spent, most of my career, developing curricula, trying to get our students prepared for the workforce. Actually, one of the last things I did before I changed my jobs was. You all can hear me, right?
Yeah.
Okay. Yeah, one of the last things I did before I left was to design a new intelligent robotics systems master's program. So, this idea of, how do you create new and modern programs built on this technology, and, how you design that's something I'm familiar with. So, so that's really great for me to be here and be able to show you how NVIDIA might be able to help you in this process, okay? So as you mentioned, I'm part of the Deep Learning Institute, which is a component of NVIDIA. And really the mission of the Deep Learning Institute is just to advance AI and get people excited about it, show people how you can use it, and to offer lots of tools to help people get going, okay? So we offer all sorts of different things, it's from teaching kits to workshops to online courses. So it kind of, speaks to this idea that you're talking about in your objectives in the project of trying to get more instructors doing this sort of thing, trying to get students to try out different ways of learning. And so hopefully there's ways that what we're doing at the DLI can plug into the objectives that you guys have in this project. So we have a very rich content portfolio across all sorts of different things. It was really interesting in the introduction when you're talking about where AI is being adopted into recommender systems, anomaly detection, self-driving cars. All the things that you were mentioning as those use cases are things that we've built courses around or built content around in the Deep Learning Institute. So you'll find things that you're looking for that are very relevant in what's happening in the world with AI. Just as a little background, the DLI is large and growing. Interestingly enough, we certify instructors to teach our workshops, and you can see there's about 550 or more. But the university ambassadors, and I'll talk about this program in a minute, make up more than half of our certified instructors. So, there's actually the Deep Learning Institute is a reasonably small group at NVIDIA, but we leverage all of you all out there at university and we certify you to teach these NVIDIA courses, and then you can deliver them to your students. And that's actually how I first came in contact with the Deep Learning Institute, was as a university ambassador in my role as an educator before I came to NVIDIA. So there's a couple different types of content that we offer in the Deep Learning Institute, and one of them is instructor-led workshops. Right now, almost all of them are being done remotely, but if your university or your location allows in-person workshops, you can do them in person as well. And essentially, there's an NVIDIA certified instructor that leads this. Like I said, that can be a university ambassador, someone like you all, you professors working out in the different universities where you are. Most of these workshops are an 8-hour long, are designed as an 8-hour workshop. I've seen people split them into 2 4-hour sessions. I personally have delivered them for my students in just one laboratory session. Because I had maybe covered a lot of the lecture material and the theory previously. So there's some flexibility in how that is, but if you're going from start to finish, they're generally designed as an 8-hour workshop. And they result in a certificate of competency. There's an assessment at the end, a student assessment that all the students have to do. And if they complete that, then they'll get a certificate from NVIDIA showing, that, and my students love this, they put it in their resumes and they say, hey, I've got this certification from NVIDIA on natural language processing or in fundamentals of deep learning or whatever it is. And that was something my students found very useful. So we also have self-paced online training. And like I mentioned, this maybe can fit in a little bit with trying to do some modern online, teaching methods. That these can be things that you can give your students as an assignment to do in your regular class, to go and do these online trainings. Like I said, they can get the certificate. And you can even use that, perhaps as a grading tool, that if the students go and complete that certificate, then they can show that, and that can be part of the grade for their course. So we've got those instructor-led ones that are a little bit more formal, where the students are interacting with the instructor. We have these online ones that are self-paced, where the students can do it on their own time, whenever they are comfortable doing it. Then another component that we have in the DLI are teaching kits. And these are content that is actually, it's developed in coordination with NVIDIA, but actually the primary content comes from universities all around. You can see from Jan LeCun, everybody knows, LeCun, and folks from Cal Poly. And so this is really good content. It has lecture slides and video, hands-on labs, coding projects, exams, solutions, and questions and solutions. And I think one of the objectives you had in this is trying to ramp up the amount of faculty members that you have that are able to teach in this domain. And perhaps these teaching kits might be a way to get new faculty in, where they have a fair amount of content to go to build, use it however they want to build it into their coursework. or even new or even existing faculty that work in this space that maybe are very busy and working on all those research projects that you mentioned, and are trying to start up a new course but don't have the time to maybe build all the nuts and bolts. A lot of this stuff is here, and it can be adapted into your semester-long classes however you want. I mean, it's essentially open source material in a way, you know, that you guys can use and adapt to however you want it to be in your classes. So obviously those teaching kits are directed for universities, but also there's this university ambassador program, and essentially you can get your faculty members or even graduate students. We've even had undergraduate students, if they know the content, you know, they can get certified and be an ambassador, and maybe for whatever student groups. If you've got an IEEE team or something that's doing AI, you can even get some of your undergraduate students. It's rare, but we've had some very strong folks you know, do that. But primarily it's made for faculty members, and you know, there's a certification process, and you can get certified, and it's no cost to you. And once you get certified, you can deliver these NVIDIA workshops for free to anybody at your university, you know, and even to other universities. I would travel to, you know, go and give guest lectures at other universities and deliver these workshops, and it's all completely free. I already mentioned these teaching kits. They also do, if you are enrolled with one of these teaching kits, we can get you free vouchers for the self-paced deep learning courses that you can give to your students and use them as assignments in the course. And so what's really wonderful, and it's one of the things that drew me to this program when I was a faculty member, is that it's all free. It doesn't cost you anything. You can give the NVIDIA content for free to anybody at your university. When you do these workshops, you get access to GPU cloud resources. So you're training everything on accelerated machines, and it's just a really great program. And you can see I get really excited about it because we offer a lot of value, and like I say, it's free. And I used the teaching kits I used it in one of my directed study courses that I had, where they got the bill of materials for the robot, and they built the robot and got some things going. And like I said, I integrated the workshops and the certification into some of my courses. So here's some more information just about you know, what you get as when you become an ambassador. Normally, if you get certified as a certified instructor, there is a cost associated with that, but we waive that cost for the ambassadors. And like I said, we also get you access to your students to the courses. And I don't know, this may or may not be something, this one down on the bottom, this new one may or may not be something of interest, but at least at my position, I was capped on the amount of money that I could make on my university contract. But in the continuing education part of the university, there wasn't a cap. And so this new program, NVIDIA can actually sell the workshops to you, and then the professor can then go and teach them in continuing education and charge fee for people to come and take that course. And it can be a way for the university or the faculty member to actually make money by delivering these courses to a paid audience. You know, like I said, usually in continuing education, not so much for your students that are in your degree programs. So there's a lot of information here. I'm happy I can share these slides with you later, so you can always refer back to them if you need to. Here's a list of some of the institutions that we've had ambassadors with, you know, all over the place, you know, all over the world. That's actually one of the things I really like. One of my jobs as a master instructor is to do the certification interviews, and I'm always certifying people from all over the world. You know, I've had people from Europe, had people from Korea and Japan and back in America. So there's a lot of people in this program, a lot of ways to connect and collaborate with folks. So this, I think, is an interesting slide because you're talking about, the whole idea here is with this project that you guys are running is how do you get adoption of these technologies? How do you get faculty members to buy in? How do you free up faculty members to be able to do this? And how do you get students, more and more students through the pipeline and trained so that they can contribute to this? And so, I know what it's like as a faculty member. You never have enough time. You're being pulled in 100 different directions. And anytime you're trying to develop a new course or a new program, it's just hard to find the time. And so, getting that time there, because NVIDIA builds up these teaching kits and has so much ready-made material, you can sort of pick and choose and develop it and sort of mold it into your own way of how to do things. And so that can save a lot of time. On the funding side, like I mentioned, a lot of these programs is University Ambassadors. It's free. There's a lot of content there, and you have access to a lot of things. And even the hardware, if you don't have a GPU cluster at your university yet, you can run these courses and the students will be programming in the actual GPU environments. And, you can do, check and see what is the memory usage. You can check on all the stats and everything in the GPUs, and you can see what's going on and gets you access to the hardware. And again, you don't have to pay for that. One of the things I do also really like, especially, we're always updating our courses, and we just released a few months ago a new version of our Fundamentals of Deep Learning course. And I really like this one about theory versus applied. I mean, obviously in these courses we cover the theory too, but there's a lot of hands-on activities. They get you into those GPUs, they get you programming, they get you doing stuff. And they're built on, most all these courses are built off of Jupyter notebooks. And so it's, an interactive programming environment. And, I got really excited, seeing how NVIDIA set up these courses. And I was, I never had the time, but I always wanted to try and convert some of the coursework that I did into these Jupyter notebooks, which it's just a really great way for the students to be able to read content, even have embedded videos and different things, and then get them right into the code. Again, sort of speaks to this idea of new types of learning methodologies. Using these interactive Jupyter notebooks is a really interesting way to get students going and learning and trying out the code. And then content familiarity. As I mentioned, there's a lot of different folks in this program. You can lean on the Deep Learning Institute instructors and the staff that we have. It's just, we're always combing all of NVIDIA's latest and greatest and incorporating that into the coursework. And so, there's just a network of people involved in the Deep Learning Institute, and is a really great way to, to get your faculty up and going. If they're either trying to learn new stuff or they're trying to get going in general with deep learning, there's a lot of resources. So I kind of covered this a little bit, sort of breaking that time barrier, but here you can see some, sort of screenshots of examples of different modules and labs and different things that are in the teaching kit. So I think that's something that could really be very useful, is these teaching kits that can save you a lot of time, because there's a lot of ready-made stuff there that you can just, plug in however works best for you in your coursework. On the cost side, like I said, you get access to all this material for free in the University Ambassador Program. You get to use the GPUs. We even do have hardware discounts where if you do want to buy, say, Jetsons or Nanos or get some GPUs, there are discount things available. We have a lot of textbooks and ebooks and stuff in these teaching kits. So there's, if you're trying to save some money, that's available too. Now, I will also mention that, beyond the University Ambassador Program, we also have what we call sort of enterprise solutions, which more are targeted towards companies. But if there is something that you want customized, if you want, to be hiring, say, master instructors at NVIDIA or solutions architects at NVIDIA that have specialized in particular, domains, you can, I don't know if there's room in the grant that you can, that you could even, purchase one of these solutions and get a customized solution where you're having experts from NVIDIA, to be able to help, build coursework for you or do modules. So I just want to put that out there, that there's a lot of these free materials for university ambassadors. But if you wanting something specific, if you're wanting to plug into some of the really, really cutting edge stuff that NVIDIA is doing, then there are also these enterprise solutions where you can get something custom built that is, maybe something, special that you're trying to break through and become a leader in. We can help you with that as well. So here's another example of the robotics teaching kit. So, of course, we do a lot of software, accelerated computing, but we do have a fair amount of content that is robotics related. So, there's, I've used this one in the past where I've pulled up the bill of materials and, purchased those, and it's pretty cheap. You can get all the little parts, and then that actually is a pretty good exercise for the students to put together the robot. But then it has all the lecture slides and handouts and all those things too. Here's just another slide, shows you some of the different exercises that you have, sort of goes through that whole autonomous, stack of, sensing, vision, dead reckoning, path planning, localization, all of those components that you need for doing some sort of autonomous robotics or autonomous vehicle stuff. So here's just sort of a couple different, I got about 2 minutes here, I've got to wrap up, but here's just some different use cases. I mentioned there's these ambassador-led workshops, and these are, again, designed to be 8 hours long, but like I said, I've sort of cut them up and done them in different ways. It's flexible. You put them in however you want, that fits in best with your curriculum. And this requires to become a university ambassador and be certified, because you're delivering the actual workshop and your students are getting certification at the end of that. You can do some other things like here, do online assignments where you sort of set these students off into do that self-paced online courses. And like I said, we can, if you get registered for these teaching kits, we can get you the free vouchers for these courses that normally would cost money. But we can get you through those teaching kits for your students to have that, for free. Then you can also do those same courses, but you can have the instructor doing it with them. So there's just lots of different ways. We put this content out there, we make it accessible to you, and then we're really excited to see how the individual faculty member can fit that into their course, or how did they put it a module here, or they give the students to do that off on their own, or so it's really just sort of mix and match however works best for you all. I think this is my last slide, or almost is. We've got a GTC as our conference that's coming up in April. It's free to attend. It's going 24/7, all day long, all week long internationally. There's links here for you to access different resources, lots of great things. And then these last 2 slides are just a bunch of links to some YouTube videos that can show you some people using the NVIDIA content and how they've used it in their university courses. Again, I'll share these slides and make sure you guys can get them, and then you can click on the links and use that however you need to. So thank you very much for the time.
Thank you for your presentation.
Absolutely, happy to do it.
Thank you. We now have like a 10-minute break, so we'll be back at 3:30 EET.
Awesome.
Okay, thank you so much.
Kevin, I have a question.
Sure, go ahead.
For your DLI students, you said they have access to workstations with the GPUs. How much time do you give them on these workstations?
So, the access to the GPUs is through the courses. It's through the courses itself. And so, like for the workshop, if you do say one of these 8-hour workshops, they obviously have it for that whole day. But then students continue to have access to that workshop for, I think it's 3 months after that. And so they can come back to the course and go back and get access to the GPU instance, for several months after the course is over. And so, when we do it, when we run the course, we actually sort of hot prepare the GPU instances so it goes very quickly to get in. But if you're doing it later after the workshop day, you might have to wait 5 or 10 minutes or so to spin up the GPU instance. But you still have access for multiple months after the workshop is over. If you're doing the online course, then whenever you log in, you have access to it. I think there is some period of time, but it's measured in months at least, so students can come back and try and do things.
Can a single experiment take hours or days?
No, well, I think what you're talking. So let me make sure we understand each other. That the GPU access is for the particular workshop and the course material that's in that workshop. It's not designed where you can then come back and run your own experiments or something separate from that workshop or that online course. For something like that, I do believe, though, in the teaching kits, there are some credits for getting AWS credits so that you can do some of your own things. So if you're trying to work on your own projects, that's not really what the GPU access is intended for. But like I said, I believe I'll have to go and double check, but I think in some of the teaching kits, there are some AWS credits that are available for doing your own projects.
Okay, thank you.
Yes, absolutely.
Thank you all. So we'll be back at 3:30. Hello, everyone.
Hello, Ahmed.
Hello. So we're back.
Yes.
So now our next presentation with Dr. Mario Rosenfelder. He's going to talk about the European academic AIR experience at talking about University of Stuttgart as an example. Dr. Mario is a research assistant at the Institute of Engineering and Computational Mechanics, University of Stuttgart.
So yeah, thanks Ahmad for the introduction. I will try to share my screen. So wait a second. I hope you can see the screen or the slides and also can hear me.
Yeah, everything.
All right.
Yes, sure.
Perfect, thanks. So thanks all and good afternoon from Stuttgart as well. As Ahmad said, my name is Mario Rosenfelder. I'm a research assistant at the Institute of Engineering and Computational Mechanics at the University of Stuttgart. So today I would like to talk about the AI and Robotics program at the University of Stuttgart, and moreover about the expertise at our institute. So my talk is mainly made up of two different parts. The first part is about the study programs at the University of Stuttgart, and the second part is an overview of our institute and its expertise, especially in the robotics field. So the first part is bigger and I'll start with it. And I would like to focus on the study programs we offer at the University of Stuttgart. So first of all, Stuttgart, if you don't know it, is located in the southwest of Germany, and the corresponding university has more than 20,000 students, and we have over 60 bachelor programs. There are mainly 3 bachelor programs, so the mechatronics, the engineering, cybernetics, and the simulation technology program, which are related to artificial intelligence and robotics. What do they have in common? So they all focus on a strong theoretical background, and they put emphasis on a broad basic knowledge such that the students are taught for a broad range of industry applications. Yeah, especially we put emphasis on mathematics, programming, and modeling. After students have finished their bachelor degrees, they can continue with the corresponding master programs. So in Stuttgart, we have over 100 master programs, And yeah, there are also the same 3 master programs. Actually, we have in the bachelor program for artificial intelligence and robotics. And since last year, we have a new master program, which is called autonomous system. I will talk about it later as well. So maybe what's special, you can directly go from, for example, the mechatronics program in the bachelor's to the master's as well, but you can also swap in between these programs without any big effort usually. Also, what's different in the master compared to the bachelor, we still have a strong theoretical background, but the students can choose their specialization subjects based on their individual interests. So there are almost no mandatory courses, but the students choose their courses depending on their interests. And yeah, most of the courses are out of the field of robotics, but also of artificial intelligence. In addition to these quite theoretical courses, each specialization subject has a practical training, which is usually conducted in the laboratory of the institute. Furthermore, in the mechatronics and in the engineering cybernetics program, the students need to do a mandatory industrial internship with the goal to gain some practical knowledge as well. So, as I said, there are mainly 4 programs related to AI and robotics. And let me briefly classify these programs and explain what's their difference in particular. So the mechatronics and the engineering cybernetics program, as you can see here, are located within the engineering faculty. Due to that, they have a great reference with respect to practical problems, with engineering cybernetics being a bit more theoretical and having a stronger focus on mathematical problems. In addition to these 2 engineering programs, let's say it this way, we have 2 further studies which are cross-faculty. Therefore, they have stronger connection, especially to the mathematics and the computer science faculty, and are thus more research oriented than the 2 programs, the mechatronics and the engineering cybernetics program, which are housed by our engineering faculty. So I would like to go on by explaining the general structure of the study programs we have in Stuttgart based on the mechatronics example and starting with the bachelor program. So it's specific for the mechatronics program here, but in generally they are all made up quite similar. It's not important that you can read each course here since it's in Germany especially and it's quite small. However, I would like to focus on the overall structure and how our programs are made up. So first of all, in the mechatronics program, we have a mandatory internship before the student starts their bachelor program, having the goal that they gain some first practical knowledge since it's an engineering course. Then the first 3 semesters, so 1.5 years, it's the goal that the students get a very strong theoretical background. Therefore, the focus is in general on mathematics, on modeling, and on programming as well. And here our institute contributes a big part, especially in modeling, since we are Institute of Computational and Engineering Mechanics. However, we also have some additional courses in numerics or in system dynamics. Then to end the second year, so on the 4th semester, it's getting a bit more specific in terms of AI and robotics. But it's still about forming a theoretical background and gaining some basic knowledge. Then for most students, the most interesting part is the 3rd year actually. Therein, they can choose their first subject based on their interest. So they elect the subjects they want to. And they additionally have practical trainings here. And finally, they conclude their bachelor thesis at the end of the 3rd year. So again, to sum up what happened, the first 2 years are quite theoretical, and the goal is to form a strong theoretical background of the students. And after that, in the 3rd year, they can choose within different specialization subjects, and most of them, so I wrote it down here, there are about 30 different specialization subjects just for the mechatronics program. And yeah, most of them can be found in the robotics field. These specialization subjects are then complemented by practical trainings. There are more practical trainings later in the master program, and I will come back there. Yeah, usually the students go on with the corresponding master program, as you have seen on the 2nd or 1st slide. However, some already go to the industry, and there they have the advantage compared to other schools or universities that they have a broad knowledge, and thus they can go almost to any industry they want to. What's different in the other two bachelor programs, so the engineering cybernetics and the simulation technology program, they both have a stronger theoretical focus, especially the simulation technology program. However, there are many similarities, and the students have not most of, but yeah, a lot of courses together or attend together. So far, the bachelor program. Let me go on with the master program, again, the mechatronics program. But I would like to highlight that the overall structure, which you can see here again, is similar for the other programs as well. The program itself can more or less be split into two parts. The first two parts is the first year. As I said, the students choose 2 specialization subjects based on their interests. There are in total more than 20 different specialization subjects. What's special about these subjects compared to other studies or other universities? So each institute offers actually one specialization subject, so just one. In this way, they can focus on their specific knowledge and teach this knowledge, and further, this motivates us as an institute to make a real effort to get good students by providing an exceptional teaching. After the first year, these theoretical courses are complemented by practical trainings, which are or can be found in the corresponding laboratories. You can see 2 quite cool examples here of our laboratory, where the students program together with a member of the institute, for example, an articulated robot, as you can see here, to dunk a basketball into the net, or to drive and navigate a mobile robot around the laboratory environment. So these are just 2 examples out of more than 10 or 15 at our institute. Furthermore, to increase the practical knowledge in the mechatronics and in the engineering cybernetics program, there's a mandatory industrial internship with the goal that students gain some deep knowledge according to practical problems and the industry itself. Finally, which is another key characteristic of the program in Stuttgart, the student write 2 theses. So a student thesis, which is a bit smaller than the master thesis, and the master thesis at the end of the studies. And these theses need to be done in both specialization subjects. So far, the mechatronics program. Let me come back to the other programs for a brief overview. So the engineering cybernetics program is almost the same. It's a bit more theoretical and mathematics. So there are a lot of same specialization subjects, but also a little bit different ones. The other 2 programs, so the autonomous system program and the simulation technology program, are more theoretical, since they are connected to the mathematics and computer science faculty. So the goal of these 2 programs is to qualify future researchers, where on the other hand, the goal of the engineering cybernetics and the mechatronics programs, the goal is more to provide exceptional students to get into the industry and become engineers. So to conclude again, in brief, what are the master programs in Stuttgart? They are built on the corresponding bachelor's program. They also have a strong theoretical focus. However, using this wide range of specialization, there's also a practical aspect in the studies. For example, using the laboratory experiments or the industrial internship. So such that you can get an overview, we have about 20,000 students at the university in Stuttgart. How many are doing the programs in AI and robotics? So the biggest one is actually the engineering cybernetics one, with about 50 outgoing graduates each year in the bachelor's and in the master programs. The simulation technology program is quite small, since it's research oriented, having about 10 to 20 students each year graduating. So with these numbers, I conclude the first part of the presentation and go on with the robotics expertise at our institute. So in general, the knowledge in robotics is located in our mechatronics and control group. Moreover, there's a large group of our institute working on multi-body system, which is related to robotics in general. So let me briefly introduce a few people down here and their interesting projects. So the first person I would like to introduce is Henrik Ebel. He's working in general on distributed robotic systems, especially their control and organization schemes. So as you can see here, for example, he was working on a group of omnidirectional robots driving in a formation along a desired path. And yeah, he developed further based on this a scheme where a group of omnidirectional mobile robots cooperatively push an object along a desired path, as you can see up here. And this group or whole group works autonomously, so they adapt their formation self-reliantly based on the task and the object. Most of the experiments you can see here were conducted in our laboratory using, for example, the robots here, which are custom built with really inexpensive hardware. The second person I would like to introduce is Hannes Eschmann. He's also working in the field of swarm robotics, especially a theoretical focus. He focuses on learning-based approaches and uses Gaussian processes to estimate and compensate unmodeled effects like slippage or friction parameters, as you can see here. We further introduced theoretical guarantees based on these approaches.
Mario, you have just 1 minute, please.
Okay, thanks. I will come to an end short. So the third person is Wei Lu. He's working, in addition to the wheeled robots, also with aerial vehicles and merges both types of robot to an heterogeneous swarm. So he's working a lot in the lab, as you can see here, and he has a high practical knowledge. The last person is myself in the robotics team. So my research area is also in the distributed control of mechatronic systems, especially of heterogeneous robot swarms, meaning the cooperation of mobile and flying robots. And we also have here, or I developed some non-holonomic mobile robots and control them distributedly using a nonlinear algorithm. So on the last slide, I would like to introduce some industry projects we had during the last years. So as you can see, we have in Stuttgart a very strong industry. You all know, for example, Daimler and Porsche and Trumpf. But we also had some machine learning projects, for example, with some smaller companies around here. So with this slide, I've finished my presentation. Thanks for your virtual attention. If you have any questions, please feel free to ask or message me. Thank you.
Thank you, Dr. Mario, for your presentation. Now, with Professor Manal Jalloul, talking about the role of AI in transforming Lebanon's economy. Professor Jalloul, she's a professor in the American University of Beirut. She's a researcher, AI expert and consultant, certified trainer and entrepreneur. Professor Jalloul.
Yes. How are you? Good afternoon, everyone. I hope you can see my screen.
Yes, everything's perfect.
Okay, great. Thank you so much. It's a pleasure to be here among you. I'm really honored to be speaking at this workshop. So first, I'm going to briefly introduce myself. So I'm Manal Jalloul. I am from an academic background. I teach at the American University of Beirut. However, I have a lot of common with Kevin because 2 years ago, I've got affiliated with the NVIDIA Deep Learning Institute. So because of my passion in AI and my passion towards accelerated computing, I got in contact with NVIDIA, and through the NVIDIA Deep Learning Institute, I've been certified as a trainer and a university ambassador for the American University of Beirut. And it's been a great journey throughout. So maybe I'm going to touch on that in my presentation today. And as well as that, last year I founded AI Lab. So I'm also going to talk about my experience in AI Lab. AI Lab is a tech hub, if you can say, for artificial intelligence. It is an AI startup based in Beirut, Lebanon. We have become the NVIDIA Deep Learning Institute certified delivery partners in Lebanon as well as in the region. And we also provide consultancy services, solution development services in AI. And I'm going to talk about that experience as well. So AI is the new electricity. It is Life 3.0, and the excitement the community is feeling about AI is enormous. And it is basically for one simple reason: AI has the ability to just combine information, combine data from all of humanity, and that's impressive. So with AI, there is the possibility of solving problems that haven't been solved before. And we are starting to see that. We are witnessing the great impact that AI is being, affecting our lives as well as industries as a whole. So what is that caused machine learning to have this big bang and to this revolution? Well, three things happened exactly almost at the same time that caused this great revolution in machine learning and AI and caused this great buzz in the community. Well, first, in 2012, we witnessed this impressive improvement in deep neural network solvers and techniques for solving them, and architectures that like convolutional neural nets that have provided impressive results when it came to computer vision. And then we had pretty much a lot of architectures and frameworks that allowed for these deep neural networks to be solved in solving them more tractable. And then we witnessed this big data movement with 2.5 quintillion bytes of data generated every single day. With the advent of our smartphones, can you imagine the amount of pictures that are being taken every day? So all of this data, this huge amount of data, provided enough data to train these deep neural nets. But then we still needed one extra component just to make it really happen. And that was this GPU in the middle. That GPU was this powerful engine that allows you to train the huge amount of data on really complex deep neural network architectures within a reasonable amount of time. And now you may have models that are very highly accurate, and sometimes even more accurate than a human being. Computer vision models that can classify images with a higher accuracy than even humans. And that is possible because of the combination of these three components. So nowadays, we're seeing the impact of AI all around us in our everyday life. So from Siri, Google Assist, they are simply reducing the barrier of entry into the online world, from their ability to listen, to hear what you say, to comprehending to what you say, to search, and then to speak back to you. So these are capabilities that are really impressive and being facilitated under the hood by the power of AI. And then you look at Netflix and Amazon and their ability to look and sort through endless categories to fetch back exactly what you need, and with their recommender systems and so on. And then when you combine computer vision with robotics, you enter this new world of self-driving cars, which is, it will drastically change the automotive industry very soon. So we're starting to see the change, but the real impact will be witnessed in the very soon next few years. So again, deep learning and AI are changing the face of all industries, whether in robotics, in healthcare, with novel algorithms for cancer detection, drug discovery, genomics, for media and entertainment, in the game development, in digital content creation, and these new deep neural network frameworks that are providing capabilities that we've never been capable of achieving before, in finance, for trading strategies, fraud detection algorithms using AI. So across the industry verticals, we are witnessing the effects of AI and revolutionary algorithms that are giving us impressive results. So according to Forbes, the return of investment of AI to the world economy is expected to be around $15 trillion. Again, this is maybe it may be a figure, but I believe this is not exaggerated. So by 2030, according to Forbes, AI will create an estimated $15 trillion of GDP growth. By 2025, the global AI market is expected to be almost $60 billion. In 2016, it was only 1.4 billion. In the US alone, $10 billion of venture capital is being invested in AI. So AI is the future. Like, this technology is changing the face of industries, and it is the future. In China, the amount of Chinese patents grew by 190% in a 5-year period. 75% of executives believe they risk going out of business in 5 years if they don't adopt AI. And 96.4% of executives reported that AI is the #1 disruptive technology that they are investing in. However, on the other hand, IDC estimates, again, that at least 80% of all applications will have an AI component by 2020, and therefore there is an urgent need for the words developers, data scientists, and researchers to get practical training on the use of the latest tools, the latest technologies for artificial intelligence. And there comes NVIDIA Deep Learning Institute in the picture. So Kevin have already done the introduction and told you about the NVIDIA DLI. However, I'm going to reiterate a little bit on touch up on some of the points that he have mentioned. So I've had a 2 years impressive journey with DLI, first as their certified instructor, and then as a university ambassador for the American University of Beirut. And through the NVIDIA Deep Learning Institute, we provide hands-on trainings in the fields of artificial intelligence, accelerated computing, and data science to developers, researchers, and these trainings are either offered face-to-face, but again, now because of the corona, we are also providing trainings online. And through these trainings, every participant is given access to a GPU-accelerated workstation in the cloud to do all the hands-on exercises. And these stations have been pre-configured with all the tools and frameworks needed in order to reduce, the headache of setting up environments. And through these trainings, the really impressive part about them is that you get to learn, the really latest frameworks, right? This is, of course, a mix between theory and hands-on. But when you go to the training, at the end of the training, it's like you've learned something that is state-of-the-art tools, state-of-the-art frameworks that allow you to directly jump and using those skill sets in solving your own problems with deep learning and AI. So in order to bring the power of DLI to Lebanon and in the region, I founded AI Lab. And an AI Lab is a company based in Lebanon. It has become a certified delivery partner of NVIDIA in the region. Now, in DLI, as a university ambassador, we're allowed to give our trainings for free for university staff and academics. However, how about developers? How about enterprises? How about startups in the region who want to upskill and reskill their employees and their workforce with the needed technologies in order to move on into this future of AI? So through AI Lab, we are bringing this expertise, we are bringing these NVIDIA trainings and workshops to the industry, in either enterprise like company trainings where we dedicate and provide the NVIDIA hands-on training for the employees within a given company, and sometimes we're offering our workshops for public attendees, for whomever would like to explore and jumpstart into AI. They can join our trainings and workshops. So at AI Lab, we aim to help students, researchers, and developers improve their skill sets with AI and equip them for the jobs of the future. So some people have already graduated from their university, they are already working, but they know that the AI is here and they want to improve their skill sets. So again, they can come to us, join our trainings and benefit from the very advantage of gaining access to NVIDIA Deep Learning Institute's complete curriculum of hands-on trainings and workshops, which range from getting started all the way through advanced workflows, self-driving cars, and healthcare and other industries. So in AI Lab, we have 3 objectives. First, to learn, for people to gain the AI skills that they need in order to improve their careers, and also to innovate we provide consultancy services, solution developments in AI to startups and entrepreneurs, and as well as enterprises. And I'm going to talk about this experience in a bit. And we also aim to build up an AI community in Lebanon, as well as in the region, for all people interested in AI to interact with each other, benefit from face-to-face events, to form genuine connections, benefit from each other's expertise. So this is kind of a glimpse of some of our DL or deep learning workshops that we have offered either through the ambassador program. So these are some workshops that we've offered in the American University of Beirut. We've received impressive feedback from all attendees, and people were very excited about the way these trainings are offered, and how they are a mix between both theory and hands-on, and where they can actually apply whatever they learn in a real-world project using GPUs in the cloud. We've also offered our trainings in universities in Saudi Arabia, in United Arab Emirates, in Egypt, in Turkey, as well as many other universities in Lebanon. We've also offered our workshops by partnering AI Lab with the Continuing Education Center in AUB. And as Kevin said, we've had that experience of collaborating with the Continuing Education Center of AUB in order to offer our trainings and workshops to the public. And we had a lot of attendees who signed up for the workshops, and very good feedback was received. And recently, just a couple of days ago, AI Lab has also joined NVIDIA's Inception program. And maybe we don't have enough time to talk about it, and Kevin didn't mention the Inception program. And this is a program to foster AI startups and to give them enough support, whether from AI expertise to improving their skill sets, to maybe joining meetups in AI, as well as some discounts on hardware by NVIDIA. And so we're very proud to join the Inception program. Now, this is some of the projects and some of our clients that we are working with by offering our consultancy and solution development services. So we're working with the Decentra, and this is a startup based in Lebanon. And this startup is working in the self-driving car industry, developing a fleet management application. And we are at AI Lab, we are developing the intelligent video analytics pipeline for their application, specifically looking at models for lane detection, for pilot assist by detecting face detection and monitoring security factors inside inside the car, and some other issues there. We've also worked with InnoVenture, and this is a company that are building, also a startup that are building a mobile application for fraud detection. And we are working with them in building the computer vision models for that particular application. We're working on and they are targeting basically fraud detection in the pharmaceutical field. So we're working on developing algorithms in that space. And also we've worked with 3D Scales. This is a 3D printing company building a state-of-the-art 3D printer. We are developing deep learning computer vision models in order to improve the workflow and efficiency and accuracy of the 3D printing process. We're also working with a company called Resico, and this is a sustainable circular. Yeah. Almost done.
Less than a minute, please. Yeah, less than a minute, please.
And that's the last slide. So for Resico, we are working on building up an intelligent video analytics pipeline for waste management, and specifically we're looking at the monitoring, detection, and classification of waste, which will improve the efficiency of waste management in factories as a whole. So just to wrap up with this say from Harvard Kennedy School, no matter how small a country is, with technology you can always improve it. So one could imagine a small technologically advanced country developing an accelerated technology edge that facilitates extreme economic growth, far beyond what would be normally expected of a small country. And that's my personal vision of a small country such as Lebanon, with our landscape of entrepreneurs and our AI skills and expertise that we are building. We hope that we can drastically improve our economy. Thank you so much for listening.
Thank you, Manal.
Thank you.
Thank you.
Thank you so much for the presentation. Now with Professor George Casellas, talking about the European academic AR experience, University of Granada as an example. He's an associate professor at the Department of Computer Science and Artificial Intelligence, University of Granada. Professor Casellas.
Thank you very much. I'm gonna share presentation. I believe you are seeing the presentation, right? Okay, thank you for all the previous presentation and talks. Very interesting as always. Well, I will try to quickly explain the situation here in the University of Granada and also try to do a global view about data science. So I will talk about programs in the University of Granada, educational resources we have here, indicators and some data about employability, and finally collaboration with industry. As regards programs, well, as I introduced in a previous workshop, the University of Granada has 103 bachelor's degrees, 112 masters, and 28 doctoral programs, with a total of about 60,000 students. Here you have the number of graduates, not the number of students, but the number of students that finished the degree on bachelor, master, or PhD. Of the last data I was able to get. This is from 2017, 2018. So you can see here more or less there are about 7,000 students that finish the bachelor degrees every year, and about 3,500 students of masters. Focusing on artificial intelligence and robotics, among all the knowledge area that we have in the University of Granada, that it's about 170 areas. I choose these 6 areas that I think they fit more properly with artificial intelligence and robotics. So we have a computer science and artificial intelligence department, an area where I belong, and all the staff of this project belong. We are 72 permanent staff. A part of that, we have about 30 students PhD students that they also teach. There is another knowledge area on languages and computer science that they have 52 lecturers. And also we have a computer architecture and technology with 34, the electronics with 21, signal theory and communication, and electronic technology. So in total, we are about 200 permanent lecturers on artificial intelligence and robotics. As you may know, well, the University of Granada is very well ranked on the topic of artificial intelligence and computer science in general. Among all the bachelor and masters that the University of Granada offer, maybe these 5 represent the closest one to the topics we are interested about. So we have 2 bachelors, one in computer science and another one in industrial electronics, 3 masters in computer engineering, data science, computer engineering, and industrial electronics engineering. To understand these degrees, it is important to put in context the education in Spain. The structure of universities curricula in Spain is based in general on a 4 year of bachelor plus 1 year of master. So it is different from most of the models follow it in the rest of Europe. Actually, where they, in general, they follow a 3+2 model. So Spain is closer to the model, follow it in North America or Asia. As regards the number of credits, the European Credit Transfer and Accumulation System, as you may know, one ECTS is equivalent to 25 hours of student work. And in this bachelor and master's, the degree of attendance is 40%. So one credit is equivalent to 10 hours of classroom teaching. Okay, so as regards robotics, the University of Granada is not very well developed in this field. So it's partially covered in some subjects and of the bachelor and master's degrees in industrial electronic engineering. So more specifically, for example, in bachelor in industrial electronic engineering, we have these 3 subjects that are close to robotics: automatic, industrial robotic systems, and intelligent control. By the way, I teach this third one, the intelligent control. In master in industrial electronic engineering, we have mobile robotics and neurobiotics that are also closer to these topics. But as I say, robotics is not so very well developed as, for example, our colleagues of PISA. As regards computer science, we have this bachelor in computer science with this structure that I will not explain very deeply because you have the information in this link is in English, so you can consult more data about that. Just for a general picture about that, we have a basic training with 60 credits, compulsory courses of 90 credits, and then we have 5 specialties: computation and intelligence systems, software engineering, computer engineering, information system, and information technologies. So the student can choose one of these itinerary to specialize within computer science in one of these topics. Here you have more data about number of subjects and so on. As I say, you can check the link below, which is explained in English with more details. Talking about artificial intelligence in this bachelor in computer science, here we have the more or less the ones I chose. I think it's more or less all of them. 24 subjects that we teach. All of them are delivered by my Department of Artificial Intelligence. So we have subjects on algorithmics, of course, introduction to artificial intelligence, information system, model of computation, machine learning, I don't know, meta-heuristics, intelligence system technologies, business intelligence. It is the closest to data science that we teach here. Information retrieval, system simulation, computer vision, game programming, etc. So here you have the year where we teach and the semester first or second semester of each year. Sorry, again, you have here a link with more details about that. So before going on with the University of Granada, I would like also to take advantage of this talk to also briefly talk about data science teaching in general, first in Spain and then worldwide. Because, well, as you know, data science is an interdisciplinary workspace that includes many processes. It's not exactly, or it's not equivalent to machine learning. It's not completely within artificial intelligence. It's more than that. It's, and as you know, it is arising as because of its high applicability for many topics: health, business, marketing, financial markets, transportation, communication, etc. So I think the world is moving on to adapt to this new reality. For example, here from the the report in the computing curricula series made by the Joint Task Force on Computer Engineering Curricula Association for the ACM Association and IEEE. They say in this report that the computer engineering curriculum should allow exploration of new inventions that have yet to emerge as viable technologies. And among them, they talk about big data, data analytics, machine learning, intelligence systems. So I feel there is a need to start to adapt some of the curricula to integrate more deeply data science. Also, we have the report of the global competency model for graduate degree programs in information system made jointly by the ASM Association and the Association for Information Systems, and they talk about the competencies in selecting and using appropriate analytics methods to identify the appropriate analysis methods for the given tasks, use of analytics platform, reports and results of analytics tasks. They also talk about the need for students to get competencies about select and apply advanced computational approaches to identify meaningful patterns and trends, decision-making activities, create visualization, so on. If we know, well, about job market, data science is very interesting, or as they say in Harvard, very sexy profession. Well, there are many forums or many places where they are talking about the importance of data science for the next job market. If we analyze the situation in Spain, here I have a table with well, I analyzed it 47 degrees. I think was about, I check about 60 teaching guides of different courses. And here I have a choose of how the data science is being using in Spain, is being considered in computer science bachelor in Spain. And here you have some results. It's interesting, the last column with more or less my subject opinion, of course, in which degree the affinity of the topics of this subject is closer to a more or less an introduction general to computer science, to data science, sorry. Here you have some more results. So it's interesting to see, firstly, that data science is not a name to be used in this subject. Of course, it is because this curricula was developed 10 years ago. 10 years ago, this name was not properly coined as it is now. Also, I realized there are some universities that are not considering at all data science. However, if we see the new proposal that is being introduced in Spain about bachelors, as you can see here a list of very new bachelors focused on data science. Yeah, I'm not talking about computer science in general, bachelor on computer science, on data science. So it's interesting to see about that. Also, in worldwide, we have different examples in the University of Oxford, Cambridge, Imperial College London, or in Switzerland, we have different consideration for including data science, sometimes with some subjects in the bachelor, other times even with a master specifically for that. Here you have some example about that. And also outside Europe, we have, for example, MIT, where they have some specialist degree in computer science, economics and data science. We have the Carnegie Mellon, for example, is very interesting because it offers a large group of subjects in machine learning and advanced data analytics. Stanford University, itinerary information, Harvard. We have here also some other results of in Asia, as in Singapore, or for example, China or Japan, where they are introducing data science as a bachelor. So I think the future is part of that. Okay, getting back to the University of Granada, I will talk about educational resources. Here we have more or less a sum up of the resources I was able to gather during the last 4 or 5 days. I was contacting with some of my colleagues, and this is what they say to me. So we have resources about hardware, about computing for artificial intelligence and data science. Here you have a sum up of that. All of them are from my research group.
Professor George, just 1 minute, please.
Well, I think according to my, well, I have a minute and a half, I think, according to my clockwork. Okay. And I was checking that. Okay, so we have a server for high supercomputer. Well, also some robotics, as we can see here, etc. Okay, about indicators and employability, we have here some results about the output or the results of the students in industrial electronics. Also about the employment status after 1 year of these students. As you can see, it's quite high. And this is about computer science. So as you can see, we have we receive about 250 new students in computer science every year. About the employability, you have, as you can see, most of students, more than 90% of students, they get a work in the first year after finishing the degrees. Also here you have some data about data science. And finally, 30 seconds more to finish with the collaboration with industry, because you also asked me to talk about that in the presentation. This is some of the companies where we have been collaborating in robotics. And as regards data science, it is huge, the number of collaborations. So I always only focus on one of the institute, the research institute, the one I belong, or all the staff of this project. And here you have some of the results. So we have many collaboration with many countries, many companies. Focuses on energy, industry, for generation, digital marketing, dissemination, tourism, security, defense, technology, edge computing, where it's, as I say, there are many collaboration with industry. You have here a link for getting more information about that. And that's all. Thank you very much.
Thank you, Professor George.
Thank you.
For this presentation. Now we will have the Jordan Design and Development Bureau, the JODB, with Dr. Rad Al-Wardat, who's the head of research and scientific corporation, and Dr. Ashraf Ahmed, who's the director of the National Incubation Center. Dr. Radi. Dr. Radi, you have to unmute.
Share my slides.
Yes, please.
Okay, thank you for the invitation to participate in this distinguished workshop, and it is actually it's a great pleasure for us and privilege for my organization.
Dr. Radi, you want to share your screen? We're not seeing your slides.
Yeah. Okay. Can you see my slides? I have shared my screen. Is it?
No, we don't have it. Nope.
What's wrong?
do you see the green button?
Yeah, share screen.
Yeah, select it, then select the one with the screen. Select the thing with screen under it, then press share.
After share. Wow, what's
Yes.
Okay. So I'm so sorry. This is a new laptop. It was.
It's okay.
Okay. Actually, it's my pleasure to be here today. Our organization, as it is known to the Jordanians, it was called CADB before 2 months. Now we have the name has been changed to Jordan Design and Development Bureau. This center is part of the armed forces, and it is now 20 years old. During the 20 years, past 20 years, we have provided solutions, products to the armed forces and security agencies in different fields. The last year, as other organizations, we have responded also to the pandemic, and we have shifted to provide to the community medical and medical equipment and supplies. So this organization, it is a non-profit organization. It is pure governmental. So we are responsible for helping the armed forces and helping our national and governmental agencies to find solutions and to adopt technology, transfer technology through a collaboration with the academia, collaboration with our partners from the industrial community, and we have different JVs in this in our industry. We have 12 companies so far. They represent 3 sectors. One sector is for military equipment for land systems, weapon systems, aerospace, and any other products that are related to the to provide defense equipment to our armed forces and the armed forces in the region. The other one is the technology and electronic and communication systems. And the third cluster, which is new, it is an ICT, an IT technology, and ICT, artificial intelligence, cybersecurity, and virtual reality, plus robotics. So we have in every sector, we have some products, and we provided products, and we still doing R&D in different areas to provide more solutions and to adopt the latest technology to find solutions to our partners. We started in 2003 establishing some plants or some factories. In 2003, we established the Jordan Light Vehicles. We have another one, JOSCure International. It is a company that is responsible for providing security solutions. Jordan Manufacturing and Services, Prince Faisal Information Technology Center, First Armor. In 2003, we established the most advanced CNC machine. 2008, we established a plant for manufacturing ammunition. We have a partnership with Wiscam. This is a well-known and reputable company in maintenance. We have a maintenance center with Wiscam to maintain, support the camera systems for aircrafts. And we have also other companies. They are merged together. Now we have these companies on the ground. They are located in one industrial park, and these, all of them, they are doing, they are compatible. They are doing the same products. Some of them, they support the production by providing parts. So when we talk about robotics, we manufacture the parts, like the parts, we manufacture them in one place, then we assemble in another place. We have also a partnership with the Optronics with Aselsan from Turkey. So many products that are designed and manufactured in our organization, they comply with the military and military standards. So we collaborate with other suppliers, with our manufacturers, to reach that standards, and sometimes we transfer technology and we produce some products jointly. In R&D, actually, we started R&D and collaboration in R&D with our national universities, and it is not. I'm talking now from my office. It is located in in the University of Jordan. And we established an office to start R&D and collaboration with academia from the undergraduate projects. So we issue a call every year to the students to compete to have their projects funded by our organization, and we support them during their projects, during implementation their products. Then we take it to the next level in our organization. In our product portfolio, let me brief you about some of our products. They look that most of our products that they are in military, but actually we have in the third sector, we have in third cluster, we have too many products that are related to technology, to IT and technology. These are in pure military products, and they are in weapons. So in electronics and electrical systems, we have too many products that are related to computer engineering, and some of them are related to computer engineering, and some of them to telecommunications. So we have jammers, we have lights, IR lights, we have anti-drone systems, vehicular control systems, blue force tracking, GPS, blue force tracking. We also in optronics, we have too many different products that are deployed in military, and they make our main battle tanks or our aircrafts work, and the night vision systems, camera systems, and the full range of optronics. And this is for ammunition. This is and these are examples for our response to the latest pandemic, and we provided some items because we are already in our industry. We have one plant that produces the military gear. Then we shifted them to be for medical equipment, for mask, face shields, coverall systems. Also, we have about to produce to manufacture our ICU ventilator. These are also some of the medical equipment. We have medical solutions for bed mobile ICU hospital and sterilizing tunnels. And too many products that we were tasked to do during the pandemic because of the shutdown, the lockdown. During the lockdown, there was too many. There are shortage in many of the products in the market or the region. So we managed to provide some of them. In the second cluster, we have some of the products. They are in the R&D, if we want to call them in technology readiness level. Some of them they are in 5th, they are in 6th. Some of them they are below 5th TRL 5. But we are shifting now to technology projects, mainly in aerospace, telecommunication, and autonomous systems. So in aerospace, we have developed UAVs, too many types of UAVs, in fixed wing and VTOL. In autonomous systems, we manufactured some of the UGVs for special operations, for special tasks in demining also. So we also provided solutions and command and control systems, various types, on also in counter drone systems, because once we have acquired experience in developing the UAVs, then we are making our the countermeasure for them. So because they are a great threat, and these systems, they employ the artificial intelligence, they employ the latest technology, and such sophisticated UAVs. And we have also established the National Encryption Center. National Encryption Center, we provided solutions to some of our organizations, not only in the military, also in our commercial also sector. In cybersecurity, we have established our cybersecurity academy. This cybersecurity academy it was recommended by the armed forces to be established to the nation. So we provide the cybersecurity training not only to the military, but also to all the national, the governmental, the banks. Also, this is linked with one of the best academies in Europe. It is PGI, Protection Group International, which is one of the best governmental organizations in academies in cybersecurity.
Dr. Radi, لو سمحت 1 minute, please.
Okay, the virtual reality lab, and establishing our virtual VR lab. We have established our VR lab in HTU campus, and we offer this to the students. So students, they can access to this lab, and we work jointly with not only with the STU, with other universities to develop also solutions using this lab. 3D printing also, we have invested a lot in 3D printing because we are already involved in R&D and design for different types of, we build our prototype within our facility. So, but not only it is open for our organization, it's open for the R&D community. In this workshop, we are here to collaborate with the academia to transfer technology from the academia to our industry in AI, since we have a lot of fields that can benefit from AI technology. Thank you for your attention, and I'm here. Thank you for once again for giving me the opportunity to talk about my organization, and I welcome participating in such workshop in the future. And I apologize for on behalf of Dr. Ashraf, because he had the presentation about the new vision about employing the AI in details in his projects, but he is, for unavoidable reason, he couldn't be here. Thank you very much.
Thank you.
Thank you, Dr. Radi.
Thank you.
So now let's have your questions or comments to the presenters through the chat box. We'll have 10 minutes for your questions. So if you have any question, please pass it through the chat box so the presenters can answer them.
Ahmed, I suggest that you announce the survey thing, and while we're doing that, we can accept questions.
Sure, Professor Wais. So actually we have a survey. If you can fill, it's going to be beneficial for our project. So we need your feedback. I will pass the survey link through the chat box. We will be appreciated if you can all fill these surveys.
There is a question to me, and this question is there any cooperation between the different universities participating in this workshop? Yes, of course. We already have some collaboration among ourselves before among the partners before this project, and through this project we hope that we work together utilizing the expertise from the European partners and the generous fund from Erasmus Plus to develop new programs and to enhance our expertise in these areas. And we also hope that the outcomes of this project will be available to other universities and other programs in Jordan, Lebanon, and the area as well. Thank you.
There's another question from Dr. Laith Sawaqid. Where's the AI from the fourth industrial revolution? Dr. Laith, if you can answer, please.
I'd like to give it to Kevin, if you like. Kevin, would you like to answer this question?
Which question was that? How does it fit in with the fourth industrial revolution? Is that the question?
Yep.
Yeah, well, I mean, Industry 4.0 is what everybody's talking about. Trying to have digital twins to where you can work all of your solutions in simulation before you are able to, put it out on the floor. The data science, I forget which university was talking a lot about the data science. That is really big piece, being able to collect tons of data from all of your sensors on your manufacturing lines and being able to analyze all of that and make decisions and be able to improve your throughput through your manufacturing. Obviously, all of you have seen those videos of the Amazon fulfillment centers where 90% of everything is automated. There's just huge amounts of places where all manufacturing industries can really improve things with using AI and sensors and computer vision. So I mean, there's just a lot of work to be done. When I was, all of the university has been showing those students that are graduating in these programs are, getting snapped up by, all of those, industrial automation is just huge. So it's a very, very large growth sector.
Yes. About the question, I think this is for me from Kevin. What's the next step in this project? Are there already detailed plans to compute each of the work products? In fact, yes. I'd like to share with you my screen for a little bit. This is a high-level overview of the plan. As you see, the work package number 1 for 3 months is the surveys and the preparation work package. I cannot go in much detail, but this is over a span of 3 years. We hope to develop these new programs, build capacity, and equip good labs and work and collaborate with industry and other partners.
Okay, the next question from Professor Casillas. At this point in the century, no one doubts that artificial intelligence is said to be the main.
It wasn't a question, it was more a comment about the importance of artificial intelligence in the fourth industrial revolution. So actually, I didn't want to make any question.
Okay. Before going to the next question,
would you like Jorge to read it?
Well, just saying, yes. I try to ask also to the Laith Sawaqid. I sorry to my pronunciation. Asking about if artificial intelligence will be part of the fourth industrial revolution. Of course, I think we have all clear that it is, at least to me, is the main pillar of this new economic and new social revolution. And the point is, this is a trend that is going through very, very quickly. We can stop it. We cannot, sometimes even we cannot decide the direction is taking the trend. So probably the only solution is to try to run as quickly as is doing this developing in the industrial about artificial intelligence. And as I finish my comments, what the best solution to deal with that is through education, I believe. So this project, DeCAIR, will be is excellent opportunity to go on developing curricula on artificial intelligence and robotics for the new era in this century, where clearly is the future. Well, just well, just to finish my comments, I was curious that we are talking about artificial intelligence and robotics. The project initially started, as I remember, when you guys contacted me some years ago with these two topics, but recently, or maybe in the last proposal, you decide also to include data science. So at the end, sometimes we are talking only about artificial intelligence and robotics. Other times we are also adding data science. Data science is something, as I said before, in the middle of several disciplinary. Well, so my question will be, what do you think, you in general, everybody hearing here, about my comments about if it's worth to develop curricula specifically for data science, or do you think that data science should be better train it through a computer science more general? So to sum up, do you think bachelor, not master, of course, master is clear, but bachelor specifically on data science, do you think there is room for that at the university? There is industry asking for that, the students like that, we need it. What do you think about that?
I think it's needed. I think it's bachelor programs in Jordan are also 4 years. And I think it is a good idea to use these 4 years to graduate experts in data science, because it's needed almost everywhere.
Okay.
Manel, would you like to add anything? We cannot hear you.
Yes. So I was trying to answer some questions from the audience. So they are asking us what's the advantage of using AI Lab versus any other AI training institute. Well, basically because we bring the state of the art DLI, Deep Learning, NVIDIA's Deep Learning Institute training. So the complete curriculum of trainings that what we offer have been developed by NVIDIA, and attendees would receive a certificate of competency from the NVIDIA DLI Institute if they attend and take the trainings. And there's also another question. They're asking if we are making any efforts towards bringing this initiative to Jordan. And we are currently also in contact with some universities in Jordan in order to bring the ambassador DLI workshops to academic institutions in Jordan, and maybe that will pave the way towards having their own ambassadors and kicking off this DLI training there. So that's
okay.
That's all from my side.
Yeah.
Thank you all.
Fast things. There is a question about when the new program will admit students. We hope that this will happen in fall 2021. And I've shared the website of this project. We're going to post the recording and the PDF of the presentations, PDF files of the presentations. Ahmed, are there any unanswered questions?
Before going to the next question, just I want to kind of remind all to fill the surveys. It's going to be beneficial for our project. The next question, are there any efforts toward advancing AI initiatives in Jordan, like the program Professor Jalul presented?
So I've already touched on that point, and I mentioned I'm in contact with the university in Jordan to try to bring up NVIDIA's University Ambassador program to the university there, and to offer the DLI workshops for free for students and staff and academics within Jordanian academic institutions. So personally, I'm working towards achieving that, and any I'm looking forward to any collaboration with anybody in a Jordanian university who'd like to work into pushing this project forward.
Okay, thank you. In Jordan, I think people from INTAJ, the ICT Society Association in Jordan, if anybody from INTAJ is still here, I think they can answer better than us.
Yes, Dr. Raif.
Nidal Bitar.
How are you doing?
I'm fine. Nice to see you.
I was on a phone when the question was, but I'll be happy. I'm with you all the time.
Okay.
Can I get the question, please?
It is, you've seen the presentation of Manal. She talked about AI lab, which tries to help local industry in Lebanon using AI technologies. Are you aware of some companies in Jordan that tries to do similar things?
I'm aware of the lab done by Progress Soft in Jordan University. I'm sure you're aware of it. The lab that was done in Jordan University of Jordan, Doctor.
Yes.
Progress Soft, by Progress Soft.
Yes.
Is this answering a question or?
And sorry if I may jump. Also, we can consider the Fab Labs as a kind of labs that can be used for AI. We have more than one Fab Lab in Jordan.
Okay. Thank you, Yad.
Professor Ghait, there is a last question. Can this project consider a local company in Jordan working in R&D, mechatronics, AI, and innovative solutions?
Yes, we do welcome collaboration with associate partners, and we, in the future, we would like to have our students do research related to practical problems from companies and from industries. So,
go ahead, Dr.
Yeah, we welcome collaboration, and we are open for such collaboration.
Okay, I think we can take just one more last question. This question to Dr. Adel Wardat. You mentioned that there is a role of Jodbi in attracting graduated students. Is there any intention to contribute transferring knowledge to universities? Dr. Wardat, can you unmute yourself, please?
Sure. There is a plan within the organization to access also all the universities in Jordan and to support all the projects in AI. And we can also take the successful ones to the next level. And we welcome any initiative from the universities and from students and their supervisors. And we have already done 1 or 2 projects in AI. I think the Tafila University was this season, yes.
Is there any other questions? Kindly, please fill the survey. I already posted the link on the chat box many times. If there is no more questions, I just want to thank you all for participation and attending our first workshop.
Great. Great. Thank you, Ahmed, for moderating this workshop. And excuse me. And thank you our guests, speakers, and stakeholders. Tomorrow is a weekend, and careful in Jordan. God bless you, and I wish you all the best. It's always nice to see all of you. Ahmed.
Thank you all.
Hello, Clavis.
Thank you all for your presentations and for joining us in our workshop. And of course, there will be a series of workshops, and it will be honored for us to have you all more and more. Thank you so much.
Okay. Thank you. Bye-bye. Have a nice
Bye-bye.
week.
Thank you.
Bye.
Bye.
Bye,
Thank you.
bye everybody.
Bye. Thank you.
Thanks.
Bye.